All right, everyone. My name is Manny Garcia with Codenomicon. Thank you for joining. Today we're going to talk about fuzzing. We're a Microsoft security development partner. So we work together with Microsoft as a partner. We're going to talk about using fuzzing as part of your security development lifecycle and testing the products that you have. So if you look through the security development lifecycle, we've got fuzz testing as part of the verification process. And you guys might want to ask, well, what is fuzz testing? So we'll talk a little bit about what fuzz testing is. H.D. Moore, the creator of Metasploit, said it best. Fuzzing is sending invalid data to a product in the hopes of crashing it and finding possible exploitable vulnerabilities. So they're all different types of fuzzers. Codenomicon's main focus over the last 10 years has been product fuzzing. So Codenomicon is started out of Oulu University, out of research in Finland. So the research started out of Oulu, and we have an active research relationship there in Finland. Fensix is a tool that goes in and it actually does protocol or model-based fuzzing. So what this does is it actually talks the same protocols that you may have on your security equipment, your networking equipment, your storage servers, etc. But it does it in a way that a hacker would possibly do. So it intentionally sends bad data in the hopes of exploiting or finding a crash, an error condition, a fault, etc. So who uses our software? So as a security development lifecycle partner, Microsoft recommends us as a tool vendor to be used. So any software that you're deploying in your network, any software that you're creating or writing, this is something that you should be using to test against. Also carriers, any network and equipment manufacturer, any security appliance should be tested with Codenomicon to make sure that it actually passes the security fuzz testing. So let's talk about vulnerabilities. So walking around the show here, most of you probably know about known vulnerabilities. So there's products like Qualys, Nessus, other products that scan for known vulnerabilities. They're looking at registry settings, they're looking at file settings, and what they're doing is they're looking for something known with a patch. They're looking at hosts and they're looking at systems to say, hey, is there a possible unpatched system here and a vulnerability that's sitting on this box that could be exploited. The second level of vulnerability management is it's known, but there's no patch. So what does that really mean? That means that we know about it, the hackers may know about it, your company may know about it, but there's not any mitigation steps or strategies yet. So maybe at this point you might know that there's a signature, you might want to block that with your IDS, you might want to actually disable that feature or product if there's a known vulnerability there. And then the really interesting aspect is what fuzzing finds, and fuzzing finds really the known, the unknown, or known with patch, and also the unknown vulnerabilities. And you may ask yourself, well, what's an unknown vulnerability? An unknown vulnerability is a vulnerability in which we're finding a flaw in a product that maybe only the company who's produced that product knows about. Maybe it's not known in the wild, so it's not a known bug or exploit. And these unknown vulnerabilities are what hackers use. So they look at the protocols, they look at the protocol model spec, and they say, okay, I'm going to break a product, I'm going to look at that protocol, I'm going to figure out how I'm going to send something bad in the hopes of finding a crash and maybe finding an exploitable vulnerability. So that's really what an unknown vulnerability is. The difference between a bug and an unknown vulnerability is a bug is something that you know about and you haven't fixed yet. An unknown vulnerability is something that you don't know about, you haven't fixed it because you don't know about it, but maybe someone else might know about that unknown vulnerability. So let's talk about the different types of fuzzing. Anyone can write their own fuzzer. So you can write a random bit blaster type fuzzer where you're essentially fuzzing a product in the hopes of crashing it. So a good example is, Charlie Miller wrote his 5 lines of Python in which he's able to take advantage of Adobe and crash Adobe PDF files. The next level is template based. So we're taking samples and then we're taking attacks, and at that point we're sending that to the test generation engine. And so we're using known samples like, let's say, a PCAP file. And we're taking those files and we're essentially using that PCAP file and we're generating our own tests. The third level is really where you have a lot more intelligence. You're able to take the target into all the different various state machines that might exist. So that's model-based fuzzing. So you might want to do an authentication. This is really valuable when you're using encrypted protocols like TLS or SSL, and you want to be able to take it to various states and then after you've done authentication or you've done the key exchange, then you want to send something malicious and break the product or possibly break the product. So what are the different types of input anomalies? All these different things that you can input essentially can cause a possible side effect, meaning a crash, a denial of service, security exposure, something that's possibly exploitable. And you might think, well, how does this apply to me in the real world? If you guys go online, go to YouTube, and for example, recently there were some exploits known in automotive space. Now, before the CAN bus was pretty much closed up, no way to access the CAN bus, but a lot of these smarter cars actually have access to the CAN bus. And via Bluetooth, via MP3 files, via telematic units that are built in the cars now, you can actually access the CAN bus remotely. So you can do things like unlock your car. Of course, you call OnStar and say unlock my doors, and they unlock your doors. But what happens if you take advantage of an exploit or unknown vulnerability, and you're able to take that head unit or that unit that was only intended to play a CD, and now it's being used to send messages on your CAN bus? And those are the type of things that you expose with fuzzing. So Codenomicon Defensics is actually a software. It's Java-based software. It runs on Windows and Linux. We have over 220 model-based protocols that we support. We also have what's called a traffic capture fuzzer. So what is a traffic capture fuzzer? A traffic capture fuzzer is a suite that allows you to take a Wireshark PCAP file, essentially create your own fuzz test case from that. So if you wrote your own Wireshark dissector, you have a custom protocol that maybe we don't support, and you want to go ahead and fuzz test it and find unknown vulnerabilities, you would use that. Most of our protocol suites allow you to do fuzzing based upon the model, the protocol spec. And the reason why you want to do this is you want to be able to extend or exercise all states of that target. So it's the equivalent of taking your software without any source code access, no source code access needed, and putting it on a treadmill and seeing how it responds in the real world and how it handles real world type of attacks. So I know this is a little bit of an eye chart for some of you, but essentially, this is how fuzzing works. So first of all, we take valid samples of the protocol spec. So an example with an HTTP. SUT is the system under test. So maybe we're sending a valid HTTP request to the system under test. And we get a valid response back from the server. HTTP, everything's okay. And then you see in there, we send an anomalous request to the HTTP server, and then we get an error response. Typical error response, 404 not found. Okay, great, because we put an anomaly in there. You can see the GET request is anomalous here. And then we send another type of anomaly in the GET request, and then we get maybe a different type of message, an anomalous message sent back. Maybe it's an error response. Maybe it's even a memory dump of the contents of the server. And then we send another anomaly, and eventually we could possibly crash that server where we get no response back. And that's where our software would say, okay, this type of anomaly sent to this type of server would cause this type of crash. Now, the tool is written as a QA tool first. So it's really designed for you to be able to find unknown vulnerabilities and fix them in your products, and then be able to fix them before hackers or anyone malicious is able to find them in your products. The great part about these tools, though, is they're very easy to use. So if you've used any kind of tools that do vulnerability scanning, you're going to be very comfortable using this type of tool. You put in HTTP, you put in the URI, you put in the port, the target, and you hit play, and you start running the test right away. So, why are we here? Why is fuzzing important? Well, fuzzing, you're able to find those vulnerabilities. Maybe you have a vulnerability that's possibly exploitable. It exists in your code, but you don't know about it. So you want to be able to fix it. And that's why if you use fuzzing, you can find those vulnerabilities that are possibly exploitable before they get out into the real world and into your code. And we found that it's a lot more expensive to fix a bug in the field than it is to fix a bug in-house. So as you roll the software out and you've deployed it out into various environments, if you're going to go do a truck roll and replace code or replace hardware, depending on what the code is, if it's code running on firmware, then you might have to replace hardware. So if you have to do a truck roll, it's going to get very expensive for you to fix that code. Also, if you have any certifications and you have to be certified, you want to make sure you do fuzz testing before you get those certifications so you don't lose those certifications in case you find any kind of vulnerability in your software. So we're seeing fuzzing really being a requirement now. So it's really interesting because I've worked in the security field now for probably about 13 years. And I worked for a lot of companies that are here. And if you ask them, what is fuzzing or what is an unknown vulnerability, you probably get a puzzled look. Like, unknown vulnerability, what do you mean? Because it's not known. And the only way you can find an unknown vulnerability is really by doing this type of fuzz testing. So now we're seeing requirements come down from different specs. So NIST SP800, including the DoD DIACAP, also require fuzz testing. The Microsoft Security Development Lifecycle verification phase says fuzz testing is a requirement as part of that phase. So, not all fuzzers are born equal. So you want to make sure if you have a product that you're developing or a product that you're deploying, that you want to exercise that as much as possible before it gets out in the field. Not only will you have security as a bonus, but you're also going to have more robust software deployed out there. So just to highlight, the reasons why you want to do fuzz testing is you want to protect the integrity and the brand of your company. If you went over to any company that's been exploited recently, they've been in the press, and you went to them and you said, what would you do to back that incident or prevent that? They've invested a lot more resources into testing the software that they have running on their networks. You want to do it in an automated fashion. By doing that, you're going to minimize any kind of security risk. You're going to protect the brand name of your company and the integrity of your company. And of course, it improves customer satisfaction. Now, how could you use this? So if you're building a product, great, that's a requirement for fuzz testing. I also mentioned actually that there's requirements. So now there's actually carriers, large carriers in the US that are requiring fuzz testing before they, as lab entry criteria, before they allow any products on their network. Now you might ask yourself, why are they doing that? The reason why they're doing that is they require 99.9% uptime on their network, and they realize that these zero-day vulnerabilities that come out, they're compiled hours before they're released, and they're launched right away, and there's no way to defend against them. The only way you can really look or defend against them is to do fuzz testing or negative testing on the software that's running on your network. Appreciate you guys taking the time to sit here and listen to my presentation. I'm happy to answer any questions you guys might have in the audience.